Solving systems of equations using substitution. So let's look at our first example. Example 1, we have the two equations of 3x plus 4y equals 12 and 2x plus y equals 10. When you're using substitution, what your goal is to find one of your two equations that can be easily solved for a single letter. So looking at this second equation, we have no coefficient in front of the y, so it'd be easy to solve y to get a low. So I'm going to take that equation and I'm going to solve it for y. So I'm going to come down and start working out 2x plus y equals 10. So I need to get y alone, and so step 1 is going to be moving that 2x to the other side, so I subtract 2x from both sides. Just out of habit, I like it to be where I have my 2x first, and that's plus 10 because it's positive 10. Okay, now that I have this guy all by himself, I'm going to come back to him later, but we're going to write down the equation for the other side. And so I have 3x plus 4y equals 12. What we're going to do is we're going to take what we found y to be and we're going to plug it into that y. And so I have 3x plus 4 times this entire thing here. So negative 2x plus 10 is equal to 12. And now I'm going to solve it for x. So when I'm solving for x, I need to combine like terms, which to combine like terms I'll need to distribute. So I'm going to distribute that 4 through both terms. So 4 times negative 2x is negative 8x. 4 times 10 is plus 40 equals 12. Now I'm going to combine like terms. 3x plus a negative 8x is going to be a negative 5x plus 40. It's equal to 12. I need to move that 40 to the other side. And that gives me a negative 5x is equal to a negative 28. Now I need to get the 5 separated away from the x, and to do that I'm going to divide both sides by negative 5. And that leaves me with my x is equal to 28 divided by 5. I could reduce that and just leave it as 28/5. Or, since that will divide evenly, I'm going to go ahead and change it to a decimal. 5.6. Now, I know what x is. And so I am going to come back over here to the side, and I'm going to come back into that y equals a negative 2x plus 10, and I am going to replace that x with my new number for x. And so I have y is equal to negative 2 times that 5.6, or 5 6/10 plus 10. And so negative 5 times 5.6 yields a negative 11 2/10 plus 10, which is going to give me negative 1 2/10. So my y is negative 1 2/10, and my x is 5.6. And so my solution is the x and y together. So my solution is that 5 6/10, comma, negative 1 2/10. That is my solution. Let's take another one, and we're going to work through 3 of these together because there's 3 different scenarios that we've talked about so far. So I'm going to take and figure out which of these 2 can easiest be solved for a single letter, and this first one is the one that can easily be solved for a single letter. And so I'm going to solve that first one for y. So 4x plus y is equal to 6. I am going to get y alone, so I'm going to subtract 4x, and that gives me y is equal to a negative 4x plus 6. Now I am going to take the other equation, 12x plus 3y is equal to 18, and I'm going to substitute that negative 4x plus 6 in for y. And so I'm going to take 12x plus 3 times negative 4x plus 6 is equal to 18. Distribute like terms, or distribute through my parenthesis, and then combine like terms. So we have a negative 12x plus 18 is equal to 18. When I combine like terms, 12x plus a negative 12x is 0 x's, so I don't need to write an x down. 18 equals 18. When is 18 not equal to 18? The answer is never. And since there is no time that's not going to be true, that means this is actually graphing the same line in both places, and this is the infinitely many solutions. Or sometimes we will say that that means that this is a dependent system. Let's take the last example, and we are going to choose one to solve for a single letter. And so the first equation is going to be the easiest to solve, and I could choose either x or y. I think y is going to be the easiest, and so I am going to solve that first equation for y. And we have negative x plus y is equal to negative 2. And I want to add x to both sides to get it to cancel out. And so I end up with y is equal to, again, I like that x before, so x is a positive x, I don't have to write a sign in front of it, x minus 2. So I'm going to take my second equation, which is 2x minus 2y equals 0, and I am going to replace my y with what I found y to be. So this is what I found y to be, so it's going to come into that new y. So 2x minus 2 times x minus 2 equals 0. And so I distribute, and that 2x stays here. This time I'm distributing a negative 2 to both parts. So negative 2 times x is a negative 2x. Negative 2 times a minus 2 is plus 4 equals 0. Again, my variables cancel out completely. That leaves me 4 equals 0. Wait a minute, 4 can't ever equal 0. There's no number I can do that will create 4 to equal 0. Since that's impossible, there is no solution. This is the situation where we had parallel lines, and the system is classified as inconsistent.